All right, this is the Excel demonstration on how to compute variance and standard deviation. And I'm going to show you two methods. I'm going to show you kind of how to do it longhand as if we were using a calculator. And then I'll also show you some of the shortcuts within Excel. So as you had in the PowerPoint demonstration, we have some days of the week and we have the high temperature. And we're going to do some dispersion measures the variance and the standard deviation of the high temperatures for this 2-week period. So to start with, no matter how we do it, we have to have the mean. So I'm going to go ahead and compute the mean here. And remember, it's very easy just to use the average function. So I'm going to go ahead and click the drop down list button here. By the auto sum tool, choose average. And then I'm just going to go ahead and highlight just those 14 values. I could have let it go, but I didn't want that extra row included just in case I added an extra number that wasn't part of the temperature here. So, okay, so in this case the average is 56.5. Now remember, to compute the variance and the standard deviation, the first thing we have to do is take each value x and subtract the mu. So I'm going to make another column here and I'll do x minus mu. We'll just assume that looks like the mu there. Okay, so I'm going to have x, and so I start with an equals, and I just moved over to B2, and then I'm going to have minus, and I'm going to go all the way down here to the mean. And so the formula reads in this case equals B2 minus B17. However, I want to be able to copy this. I don't want to have to go down to the next one and type, equals B3 minus B17 and so on and so forth. So in order to copy this, because I want B17 to remain constant, I'm going to use the absolute reference function, or the dollar signs that designate this as being absolutely referenced. Now I can go ahead and copy this all the way down, and so I have a column here of x minus mu for each of the values. Now remember, to compute the variance, what we're going to do is we're going to take the sum of x minus mu squared. So I'm going to go ahead and do another formula here, and we'll just say that this is going to be x minus mu, and we'll just to the power of 2. And in doing that, remember, the mean deviation used the absolute value. In squaring this, we always end up with a positive value as well. So we'll just go ahead and start with an equals again. We'll take the value right to the left of us here, which in this case is C2. And to use the power of, we use a little caret symbol, the power of 2, or 2, square it. Alright, so I will go ahead and just copy that all the way down. And so now I have x minus mu squared. Now remember, the next step is to sum it. So I'm going to go ahead and sum that value. And I will use the shortcut. I'm lazy when I can be. Just go ahead and click the auto sum tool, and again, to make sure I don't include any extra cells, I will go ahead and select the cells I want. Okay, so I've got them summed. Now the next step in computing the variance is to divide the sum by n. When we're working with a population, in this case we're assuming this is a population, we divide by n. So we simply take, in this case, D17 and divide it by 14. Because that's how many values we have in this 2-week period, which again we're considering a population. So we end up with a variance of 21.67. And how far you need to report usually is 2-digit places is enough. Excel computed a little bit more than that for us. Now to compute the standard deviation of a population, all we do is we simply take the variance and we take the square root of that. So we'll use the square root function, which is SQRT, and in parentheses we put in the variance value, which is D18, and there we end up with a standard deviation. Now, as I said, that's the long way. That's the way you could compute the variance and the standard deviation if it were a calculator, but Excel, being Excel, has functions that will do this for us very easily. So I'm going to go ahead and compute the variance and the standard deviation again right over here in column F, but this time I'm going to use the functions. So I'll start with an equals. Now, I just happen to know, that I could type std, and I will then see stdvp, stdevs, which represents P for population, S for sample. Now, let's assume I didn't know that. Well, if I didn't know that, I could get the large list of functions available to me here. I could click the drop-down list there with the auto sum tool and then choose more functions. And Excel has so many functions that it actually breaks them down into multiple different categories. Well, the category that I would probably find standard deviation is the statistical category. So if I choose statistical and I scroll down the list, and more than likely it probably has, standard deviation probably starts with an S, so I can scroll down here into the S's. But in the absence of that, if I didn't know what anything did, I could actually just click on that particular function, and it does give me the description of that function. Now, that particular function, slope, will make a lot more sense as we get to the end of this lesson, or into this class. But here's the one I'm looking for. Notice we have the stdev.p, and it says, if I look at the description, that it calculates the standard deviation based on the entire population. So that's what I want in this case. So I'm going to go ahead and click OK. And now it says, okay, what values do you want to compute the standard deviation of? Well, I need to make sure that it's actually the high temperatures. So I'm going to select B2 through B15. I'm going to click OK, and there I end up with the same number for standard deviation. Now, I didn't compute the variance, but the shortcut for variance is var.p. And so you can see it's very easy to use Excel to compute the standard deviation variance. You can do it the way your textbook tells you, by just taking x minus mu and squaring it, and taking the sum of the square differences, divide it by n to get the variance, take the square root of that to get the standard deviation, or you can just use the standard deviation function or the variance function.